All right, so this is all you need to know about electricity right here. So we have the volt, the amp, and the ohm. The volt is pressure. It's electrical pressure. It is not movement of any sort whatsoever. You're going to hear me say over and over again, it's the difference of potential. And by that, we can look at this little volt guy. We can say, well, what do you mean difference of potential? And in this particular scenario, I've got this guy pushing, but I don't have another guy pushing over here. So if I had this person over here pushing on this guy's head, it would be equal, wouldn't it? And so yes. And the little amp guy would go nowhere, but that's not the case. We have a difference. If this guy's pushing with 50 pounds of pressure on his little amp butt, we have no pressure over here. It's going to go this way, right? So that's what I mean by difference of potential. There's got to be a difference, all right? So volt is pressure. He doesn't move. He doesn't move. He's just the pusher guy. All right. Then we've got the amp. The amp is the actual movement of electrons. It is this guy moving through here. Is he moving? Yes, he is. So if I want to count, I would look right here and count as each one of these things came through here. These peoples, all right? But then the ohm, that's resistance to flow. As you can see what he's doing. He's making it harder for the amp to flow. So what happens if I get rid of the ohm? It's going to flow a lot freer. What if I add another volt? It's going to push harder. It's going to go flow through there. And then the amps, of course, is how much is going to flow through it. All right? Silly way to do it, but yeah.
So amps is what's moving through the piece of wire.
Yes. Okay. So we're going to go back to that. So units of electricity. Current. Current. If you want to think about water, I guess you think about current flowing. Current. You're going to love some of this. Symbol. The symbol is I, which stands for intensity. So I. It is measured in amps, or amperes, we'll just say amps. And it's named after a guy, French guy, André Marie Ampere. So amps, it's actually A-M-P-E-R, Ampere. We'll say amps. So because it's named after somebody, we give it a capital A. It is the flow of electrons through a conductor. All right. Now we got voltage. Has a symbol of E. Stands for Electro-Motive Force. E-L-E-C-T-R-O-M-O-T-I-V-E, Electro-Motive Force. There we go. We could also think electron moving force, if you wanted. That's not quite right. Measured in volts, named after Alessandro Volta. It is electrical pressure. And as I always say, often is a difference of potential. Difference of potential. Then we've got the resistance. the symbol is R for resistance. It is measured in ohms, named after Greg Simon Ohm, and it restricts the flow of current. We could think of it as electrical friction. And not only does it restrict the flow of current, but it also causes a drop or loss of voltage. Now tomorrow we're going to get into Ohm's law and what all this means. But for about the next hour we're going to talk about the meter. But I wanted you to be able to understand, number one, what really is electricity? And hopefully I conveyed that in a very short period of time. It is flow of electrons. And now you know what an electron is, because an electron is part of an atom, right? And electricity does in fact flow from negative to positive. And we call that electron flow, theory flow. All right? But in the old days, old school, it was the conventional theory, right? Positive to negative. But it doesn't really work that way. So this is the way it works. And now we've been introduced to 3 units of measurement. We have the amps, we have volts, and we have ohms. All right, and we're going to talk about how to measure those. So everybody's caught up and good right now? Feeling comfortable? Okay. Huh? These chairs, they do. I'm sorry. Where do I want to start? All right, so we're going to start with the Simpson meter. And the thing about the Simpson meters, I'm going to divide it up into different ways of doing it. We're going to start with resistance, they're going to move on to other stuff. And it's actually quite simple to read. You just have to keep it straight in your head. And sometimes you can get a little off kilter, but that's okay. Just, say, oh, wait a minute, made a mistake. I'm going to come back to it. So a couple of things that I want you to note. Number one, we have this dial over here. This is not the one in front of me because it's got a little music note. How cool is that? All right, so we've got. What's that? What? I think it's decibels, actually. Okay, this is a little bit different. The one that I have in front of me, hang on, let me see. I think I have a picture of that one. There we go. This is the one in front of me. All right, I know it's a little light, got a little heavy over here, but you've got a on-off right here. So you've got off, DC plus, DC negative, and AC. The DC plus and the DC negative, that's for direct current. We're going to be using direct current in this class. We'll do alternating current in the next class. But direct current means basically batteries. It means that the current isn't changing directions. So that's a whole other lecture. We can get into that. But anyway, we're going to be doing this. DC plus, DC minus, really the only thing about that is it's like if you had the wires, the red connected to one side and the black connected to the other, and you realized you're backwards, instead of taking it off and reversing it, you can just flip the switch, and it's the same thing as switching these over. All right? Otherwise, it doesn't matter. All right. And so this is the on-off. When you return it, I know, make sure, I'm terrible. I leave them on all the time. I shouldn't admit that, but I do. So make sure you turn it off when you turn it in. When you're done working on it, it does have batteries inside of it for reading resistance. All right, then we've got the dial. We're going to go through this dial rather slowly, but I'm going to tell you right now that notice how there's large writing and then small writing. So if I have it on this right here, I've got a large thing and a small thing. The larger writing is the default. If you've got the wires plugged in here and here, you're going to go to the default larger reading. If you want to do something different, then you can rearrange the wires and you're going to get the smaller one. I'll get into that later, but that's what it's about. So right now we're going to start with resistance. We're going to read resistance. So resistance is over here, R times 1, R times 100, and R times 10,000. Now I want you to notice that nothing else on here has a times on it. Resistance is read completely different on this meter than pretty much everything else. So you learn to read resistance, then we go to the next thing, it's going to be very, very different. So right now we're going to be working with these, R times 1, R times 100, and R times 10,000. And that's all we got to learn right now is how to read this right here. All right? So resistance. We have R times 1, R times 100, and R times 10,000. All right, so looking at our little Simpson meter here, we are going to be measuring resistance. Resistance is what? Restriction to current. Now, in order for this meter to read resistance, what it has inside are some batteries. And the batteries, there's a couple of D cells and I think a 9-volt in there. And so depending on what I have selected is really what battery it's going to be using. So it's going to use an internal battery. It is going to put a little bit of voltage and current out of these. You can lick them if you don't believe me. And it's going to run it through whatever you want to measure the resistance of. So I brought in with me a couple of resistors. And it just so happens that the resistors that I brought in are these exact resistors. I took that picture right before you guys walked into class. And I could, if I wanted, decode what these resistors are based upon these color codes right on here. So it means something. And you'll notice the gold goes to the right. So like this one is yellow, orange, and black, and gold. And so if I look at a color chart over here, I've got yellow, as I said, is, let me see, 4. Need my pen. So yellow, we have a 4. We have, what was the next color?
Orange.
Yellow, orange,
And black.
and black, and gold. So orange is a value of 3. And black is times 0. So if and gold is the, should be gold right here, plus or minus 5%. So what that's saying is, this is, the first number is a 4, the second number is a 3, and I multiply it times 0, so it should be 43 ohms, plus or minus 5%. Now if I want to know what that is, I'm going to take my calculator and I can do 43.
So you combine the first two numbers?
Combine the first two. So this is right here. It's saying this is the first number, the second number, and then the multiplier. So the first number is 4, second number is 3, and then it's black multiplied times 10, or times 0 on this particular one. But it's plus or minus 5%. Well, why is that? Well, it'd be too expensive to make a resistor that was exactly 43 ohms. So they make it and they put a gold stripe and they say, you know what, it's gold, so it's pretty good, but it's plus or minus 5%. Well, to figure that out, what does that really mean? I could go 43 plus 5, and then I hit second and the number 2 key because there's a percent. And that's 2.5, so 5% equals. So it's as much as 45.15 ohms to as little as 43 minus 5 second percent equals 40.85 ohms. So it's going to be somewhere in this range right here. Everybody follow? Yeah.
Isn't 43 times 0 0?
This is a multiplier. It's a multiplier. So how many times do I multiply 43? Okay, let's say this wasn't black. Let's say it was red. So let's say it was red. Red has got a multiplier of 100. So it would have been 43 times 100. Or if it was brown, it was 43 times 10. So, yeah, I'm sorry. Good point. You don't multiply it. Don't multiply it is what it's saying. You don't bring it up. Now, who's got an Android? Just me? Seriously? Every single person here is the Apple Kool-Aid? All right. All right. So I have an app called Electro-Droid. And you can use this in lab. I don't care. On the test, you'll have a test question that's this. So you better know how to read this. But again, so all I have to do is go, what did I say? It was brown. I go brown. No. It's yellow, orange, black. There. 43 ohms, plus or minus. This is in your worksheet too, by the way. So I can just use this and do it really quick. So Electro-Droid is a good app. I don't know what you do if you have Apple, what that is. All right. So back to this. So we're going to read. Yeah.
I have a question. How do we get the 4085, not the 4515?
It's 43 minus 5%.
So now it's minus,
So this is the range. So this thing's got to be within that range. Yeah.
So you said, so the black, the multiplier is 0.
Yep.
And then if it was brown, the multiplier is 10. So could you explain that? Just a little bit?
Let's look at this one down at the bottom. What does that color look like to you right here? You want to go?
Kind of hard to see the color when the light's
All right.
on.
That's fine. That's a good example. Let's stick with this one. What do you guys want to call it?
Red, orange, gold.
Red, orange, gold, gold. Okay, red, orange, gold, gold.
Resistor code calculator.
Red, orange, gold, gold. Red, orange. Red, orange, gold, gold. Okay, red, orange, gold, gold. So red is what? 2. Orange is 3. Gold is, when it's right here, it's a horrible thing. It's times 10%. So times 10%. So it's 23 times 10%. So that would be 23 times 10 second percent equals 2.3 ohms. Oops. Follow?
So that one you actually multiply, but with the black,
Yep.
it doesn't mean anything.
Right, it should say 1. You know what? That should really say 1, but
Okay.
I didn't write this chart. Yeah,
So a resistor only has four bands always, or is it?
there. That's better.
Follow the order of the band.
Yes,
left,
always.
right.
And the gold is always on the far right for you. All right, but it's 23 ohms plus or minus what?
Plus or minus 5.
23 ohms plus or minus 5%. So I could do 2.3 plus 5 second percent equals, so that is 2.415 ohms to 2.3 minus 5 second percent equals 2.185 ohms. Follow? Yeah.
Will there be like a 5-band resistor?
There are, but I don't have any. So they make 5 bands.
Is that what that squiggly line is? Is ohms?
Ohms. Well, this is an ohm. It kind of looks. It's a Lululemon.
Okay.
It's a Lululemon, but I don't draw my Lululemons very well. See, it helps to have a daughter in class. She teaches me stuff like that. Dad, those are Lululemons. If you don't know what that is, then you don't overpay for your clothing. So. All right.
What about if it's going to be like times 1,000 and 10 to...
Well, I'm not going to do all of these.
Oh, we're not even going to touch this?
You can, but I'm not going to sit here and do every single color. Got it? Then multiply it times 10,000.
Oh.
What was the name of that app you were talking about?
Electro-Droid.
Okay.
All right, but And sorry if you're watching this on YouTube because I'm going to switch to the dock camera and you won't be able to see this. Or I won't. I don't know. Go ahead. You have a question? Well, it's
No, I lost it.
lost it. It was there and then it was gone. Huh? No, there's no shutter. Or maybe I won't. I have no idea. There we go. I think I got on freeze. Autofocus. Autofocus. Come on, buddy. You can do it. You can do it. I think you just did me dirty by turning the light off. Okay, so I'm going to take this little red, orange, gold, and what should it be?
2.3. No, from 2.18.
All right, so we said it's going to be somewhere around 2.3 ohms, right?
Mm-hmm.
Okay, so 2.3 ohms, I'm going to go back over this again, but I'm going to put it on R times 1 because that's going to make the most sense, and I'll explain that a little bit. And I'm going to turn it on because that's very important, and I'm going to zero it out, which the reason why I want to zero it out, always zero it out whenever you turn it on or change, because you're using the internal batteries. And as the internal battery's out, I have to tell this thing where zero is. So I have this little knob on the side here, on the front, and I'm going to zero it out. So does that look zero to you guys?
Yep.
Okay, so I zeroed it out. Now I'm going to take my 2.3 ohm and I'm going to put it on here and I'm going to measure it. And the way it is measured, and I'm going to look at that, and what do you got?
2.3.
Well, it's times 1, and I'm going to go over this again, but I just want to make a point. So that's 0, 1, 2. It's more than 3, right?
3, yeah.
Well, I tell you what, if I were to look at this, and I don't know if you can see the color very well out there, that sure looks like orange gold to me. So if it's orange gold, that would make it 33 or 3.3. Does that look very close to 3.3 maybe?
Mm-hmm.
So it's probably orange. All right. It's probably orange. All right, now we're going to go back to Alt-Tab. I want that one. All right, so we're going to go back to this. We're going to go back to here, and we're going to talk about this from current slide. Well, that just didn't work. Okay.
Can't see it though.
What?
Can't see it.
Well, then open your eyes. Computer. Wish you could do one way and one the other.
That would be cool.
I know, it's split screen. Well, you know. All right. So I want to measure something, and I'm going to go one more screen here. Okay, I've got 1, 100, and 10,000, right? So now everybody can see the.
Are we recording now?
Yeah, we've been recording. It's on freeze or something. Come on, you can do it. Now we're going to catch up. Computer. There we go, caught up. All right. So we're looking at this scale up here. And I'm going to go to my laser pointer. All right, so in ohms, see how it says ohms right here?
Yes.
That means ohms is up here. This is not ohms. So the only scale we can read is this top 0 all the way around up here on the very top. Now, you know what's fun about this? 0 for ohms is on this side, but look where 0 is for everything else. Isn't that fun? All right, so you got to remember that. It goes backwards when we switch. So anyway, so if I put it on R times 1, anything I read here is reading exactly what it says. So if I have my needle right here, how many ohms is it? 15. Oh yeah, you got it. Now you always want to try and read somewhere in the middle 2/3. Because look what happens when you get over here. The difference from here to here, that's 50. From here to here is 500. From here to here is 1,000. My dot is covering almost 1,500. So you can't read that over here. So make sure it's somewhere kind of in the middle or where you can read it appropriately. So I hooked up my resistor a minute ago, and I had it right about here. Right? So that was about 3. So rule number 1 is make sure you always zero it out. Okay, so if we go, I'm going to do this, pen, if I had my little red line was right there, what am I reading at R times 1? All right, start here. 0, how much is this? 1, 2, 3, 4, 5. That's 5.5, 6. 6.5, 7. 7.5, 8. All right, so that'd be 8. And I have another scale, R times 100. What if I switched it to R times 100, found another resistor, zeroed it out, did this, and the line was right there? How much would that be?
800.
Oh, you guys are way ahead of me. It's 800. All I really have to do is read the scale, what it is, and multiply it times whatever it says. So now it's 800. And if it was on R times 10,000, and it was right there, what would it be?
80,000.
80,000. 80,000 what? Lululemons. Ohms. Okay. All right. So let's get rid of that. Eraser.
Does that mean that it's 80,000 ohms? That's more resistance.
More resistance. Higher number. All right. So let's put it right here. What would this be?
13 multiplied by 1.
That wasn't supposed to do that. R times 1. What do I got? 13. All right. So we know that would be 13. What would it be at R times 100? 1,300, 1,300, and 13,000. All right. Let's get rid of that. This is not hard, is it?
No.
All right. As long as you stick with me, it's not hard. Okay.
So you always times it as 1, then 100, and 10,000.
Well, it just depends on what you're. All right. So, okay. So her question is it always you just do it like that? Well, not necessarily. Let's say I've got a resistor and I have no idea what colors these are, nor do I even want to know. I'm too lazy to actually look it up. Even though I've got an Electro-Droid and I can say that it's, if I look it under the light, it's probably red, red, gold, gold, maybe. But I don't want to do it. So I'm just going to go for it. So how would I just go for it? All right, I'm going to go back to this live. And you guys are there live. Is it live? Yeah, okay, live. All right, so I'm going to turn it on. Zero it out. Very good. So first thing I'm going to do, I've got an R times 1. I'm going to zero it out. So I'm going to clip the two wires together. I'm going to zero it out. And I'm going to back this up just a little bit. So the dial is right there. See the dial right there, zeroed out. Okay.
0 ohms above the dial.
So I'm going to zero it out. Could you guys see where I zero it out? I'm going to hold it up here. Okay, so it's right here, zero it out. Okay. So now I got to put it back in, right? All right, so I'm going to zero it out when I want to. All right, so I got it here. I'm going to zero it out. Now I'm going to find my resistor, and I'm just going to clip it together. And I'm going to see what happens. Hey, what do you know? How many ohms is that? 2. Okay, that wasn't so hard. Now I'm done. Well, let me see. I think I grabbed a bunch of little tiny ones instead of some really, really big ones. Let me think what else I got. All right. What's my resistance? All right. So I switched it to R times 10,000. What's the first thing I should do? Zero it out. Okay, zero it out. Put it on here. It's not too far off.
Yeah, it's not 0.
0?
Yep.
All right, you got to watch yourself because there's my resistance.
Aha.
So you actually have as a person, you have quite a bit of resistance. So I get to stop there. What's my resistance? 35,000 ohms. All right, so that's something else you have to think about. If I were to, you got to be careful because if I want to measure this resistance, this resistor right here, well, it's not going to, you have to be careful when you're, this is too low. But anyway, be careful because you can actually measure your resistance. And if I stick it in my mouth, it's going to change, but I'm not going to. So, yeah. Somebody else can.
I have a question.
Yeah.
So how do you know when to switch from 1R or R times 1 R times 100?
Okay, so I didn't bring in a really good selection. Well, let's say I'm all right. So I'm going to go back to R times 1. What do I do? Zero it out. Okay, so I zeroed out, and okay, we'll call that 0. Now I've got a new resistor, and I'm going to hook up my resistor, and I hook it up, and boom, it did that. So I just switch it. Yeah, disconnect it. Zero it out. All right, so you just have to see where it is until you get it in the middle. And now I can measure it, and we come up. Say it ends up right there. What do I got? It's on R times 100, so
200
so you have to figure out what each line counts for. So if we're down here in this range, right where this is, which is it's right here. I got it right there, didn't I? So what does each one of these lines count as? Is it 2, 2.2, 4, 6, 8? This is 3 right here, so that's 3. So that means 2.6 ohms. 2 times 100, so it becomes 260 ohms. If we're right? Okay.
So basically, since you didn't get to figure out the colors, if you can get it on 1 times 1 and it goes up to 2 or to whatever it might be.
Whatever, yeah.
And then you find the one that gets right next to it, basically.
Yeah, or I could have, tried it the other way around. So let's do it the other way around. So let's go here. I'm going to go R times 10,000. I'm going to zero it out. I'm going to hook up my resistor, and
It's not going anywhere.
it's not going anywhere. So let's try it again. R times 100. Zero it out. R times 100. I've zeroed it out, and I've got nothing. All right, so we'll try it again. So we're going to come over here, go to R times 1. I'm going to zero it out. Try it again. I've got 3.2. See how that works? So if you're wrong, it's going to be really difficult. All right? All right, so that's resistance. So what do you have to remember? Always zero it out. 0 is on this side. Try and get it somewhere in this. Well, once you get past here, it gets hard to read. So sometimes you have to, though. Yeah.
Excuse me, do you need to zero that to digital?
No. No, but you have to do the math on it. Because it won't zero it out. It'll tell you, like when you put the wires together, it'll give you a resistance. And then you have to stick with it. All right, so let's erase all this. Erase all that. All right, let's go to voltage. All right, voltage. All right, so looking back at this, well, I don't have a problem. I can see what I want to see. Looking back at this, so as far as resistance goes, we have R times 1, R times 100, and R times 10,000, right? That's it. Now we're going to go voltage, and we're going to leave everything set in here, so we have there's something I forgot to. Okay, let me back up just a little bit and remind you that when I'm doing this, why did I have to zero it out? Accurate. What's wearing out? Batteries. So if there's an internal battery, what do you think happens if I put it on the internal battery and connect this to more voltage? It's not going to be happy at all. So never, ever, ever measure voltage. Never, ever, ever measure resistance, ohms, with this connected to a live circuit. Always disconnect. Never measure ohms with an energized circuit. It won't work because this is going to get a bunch more voltage than it wanted, and it's not going to understand it, and you zero it out, and it's going to get crazy. Never. Don't do that. Okay, how many people in here are going to do it anyway? About this many. About half of you will still do it anyway. Now, I don't know if it's kind or unkind, but I kind of believe in you learn by your mistakes. So I'm not going to jump in and go, oh, don't do that. I'm just going to go, that's going to make a mess. And I'm just going to step back and let you do it. And you'll find out that the voltage we're working with isn't really going to hurt the meter per se. It's not kind to it. But in a little bit, I'm going to show you some other things where you can't do it, and you're going to blow fuses. And when you blow a fuse, I'll let you do it because I've already told you not to. You blow a fuse. You get to do a walk of shame up to the tool room. And James, he's learned how I do stuff, and he's got a little thing up there, and you tear off a little tab, like you want to buy a bike or whatever, and the telephone pole, and it's got a little tab, and you take, and it tells you what kind of fuses you have to go buy. And and the funny thing is, fuses only come in like a pack of 10, so I think he's got like a stack of them now. So I think at this point he actually goes, don't worry about it, I got so many. Because anyway, so never measure ohms with an energized circuit. Always disconnect the battery. What are you going to do? Disconnect the battery. All right, so. All right, so we're going to do voltage. Look at my voltage. I've got 2.5, 10, 50, 250, 500. 500. 500 is 500.
What's the 1,000 at the bottom?
I don't care what it says under it. That says 500.
Yeah, but what does it mean?
What does that say? It says 1 volt.
1 volt.
That says microamps. All right? The stuff underneath is written small. What does that mean?
Not relevant.
Special operation.
It's relevant. It means that it's an alternate setup. Got it? So with the plugs in here, it doesn't work there. In other words, if I want to read 1 volt, I put it on the 1 volt scale. I got to take this out, and I got to put it over here and there. So I got to plug it into a different hole. Okay, we'll get into that some other time. It's a little complicated right now. All right, 2.5, 10, 50, 250, 500. Everybody agree with me? All right. If you disagree, then you have to just sit there and silent objection. Up here, what did we measure up here?
Ohms.
Okay, this is the ohms and it's only the ohms. So now we're going to move down here. Now I want you to notice that there's black numbers and there's red numbers. The red numbers are for AC. This scale here is in red. That means that scale is for AC. So you should only be using the DC, which goes from here up to here. This is a no. That's a no. No. All right? Red is no. Let me erase that. All right. So my scale, I had 2.5. I have 10 volts, 10, 50, 250, and 500, if I remember correctly. Yes. Okay, those are the ones we have to use. We've got to make all of these fit within these three. So it's not hard. Let's start with 2.5. Which one of these, 10, 50, or 250, looks the most like 2.5?
250.
All right, so you're going to use this scale here. 2.5 goes to that scale. The 10 goes to the 10. The 50 goes to the 50. The 250 goes to the 250. And the 500 goes to the 50.
I'm confused.
Okay. Figured I'd lose a couple people there. That's just life. Sorry about that. No, it's okay. That's okay to be confused. Thank you for saying that. I shouldn't have erased them all. Let's start with the 2.5. If I want to read something on the 2.5 scale, rule number one. Everything with me is rule number one. I don't have a rule number two. So up here, we started with 0, and it read up to infinity. Infinity is this little sideways 8. When we're reading this stuff, it's very different. This right here is the maximum. That's the max. Max it can read. All right, now I'm going to go backwards one. See this 250 right there? That's the max. The 10, that's the max. 50, it's the max. So if I want to measure something that is 60 volts, can I put it on the 50 scale? No. See how that's so different than over here? It's the max. So if I want to measure as something that's 60 volts, I think this could be potentially 60 volts. Which scale do I have to choose? That's right. If I'm working in the lab and you guys are, and you've got, let's say, the little tiny 9-volt battery, which one of these scales can you use? You could use the 10. You have, though, a big 6-volt battery. Not a lot. Which scale could you use? 10. So you could use a 2.5? It depends on what you're doing. But yeah, if you're going to measure the battery voltage, it's got to be that one right there, 10. That's the most you can read. All right? All right. So that's the max that can read. So I want to read 2.5 volts. Got it? So when I put that little switch on 2.5, I need to read this top one right here. Why? Because the numbers match. And what's the most voltage I can read with the 2.5 scale? 2.5 volts. And at 2.5 volts, the line is going to be right over here. I want to erase that. Because it's the max. But what's interesting is not that. That wasn't interesting at all. What's pen is you put a point right there. So when I put it on 2.5, it transforms all this. That's 2.5, that's 2, that's 1.5, that is 1, that is 0.5. What is this here? 0.25. See what that did? It transforms it. So on the 2.5 scale, the most I can read is 2.5, and which scale do I use? The 250, but I just convert it. So let's just put a line right here. So if I had a line right there on the 2.5 scale, how many volts would I be reading?
1.6.
All right, so I'm hearing 1.6. Let's try it out. Well, how much is right here?
1.5.
1.5. And halfway in between the two, this should be 1.75. All right, so now it's just trial and error. Now we've got to figure it out. So if this is 1.5, I could go, well, that's 1.55, 1.6, 1.65, 1.7, 1.75. So that works. So this becomes 1.55. This is 1.6, 1.65. Oops, sorry, down here. 1.7, 1.75, 1.8, 1.85, 1.9, 1.95, 2. Not too hard, is it? What if it's right here? All right, so, and it's trial and error. Maybe it's 2, so you could try it. Is it 5.5, 0.52, 0.54, 0.56, 0.57, 0.58, 0.59, 60, 62, 64, 66. Did that work out at all? No, it's totally wrong. It's not by 5 or 2s. It's by 5s. It's going to change on us. So this is 0.55. This is 0.5. Oops, 0.60. 60, 65, 70, 75, 80. So this becomes 0.85 is how many volts I have. Everybody follow so far?
Yeah.
All right. What's the next thing then? It was 10 volts. Which scale am I going to read? Okay, I'm going to read this one right here. What kind of manipulation math do I have to do here? Nothing. What is the most voltage I can read on 10 volts? 10. So if it's right here, how many volts do I have? Everybody who said 6, you are dead wrong. Why are you wrong? Because you're looking at the red. That's AC. We're not doing AC. We're reading up here.
Hold up, what?
You can't use this scale right here because it's AC. AC. See, AC. We're reading DC. Everything's got to be in black.
So it's not 6?
No. Mine's right here. Is that 6?
It's not 6, it's 5.
5 point something?
See? It's not hard. You just have to pay attention. I already told you don't read the red scale. So everybody's reading the red scale. I already told you not to. They go, well, why am I not supposed to read the red scale? Well, I told you not to read the red scale because it's AC. It's right up here. So what is it? But I'm still going to read this scale here. So how much is this right here?
4.
4. How much is this? 5. So now I just have to figure out. Maybe it's by 5. So that'll be 4, 4.5. That didn't work, did it? All right. How about 2s? 4, 4.2, 4.4, 4.6, 4.8, 5. It's working. 5.2, 5.4, 5.6, 5.8, 5.8. And this is 6. So what is it right in between the two? Huh?
5.9.
5.9 volts is exactly the right answer. How much is it right here?
There's so many lines.
Right on the line.
2.6.
We are on the 10. I haven't changed it. Still on 10. Still on 10. You're right, though.
So 2.6.
2.6. This is 2. This isn't 2 here. This is 2 here. 2, 2.2, 2.4, 2.6. This is not hard. This is easy. What's the next one? Next one's 50. I'll erase everything. Next one is 50. 50. 50 volts. All right, which scale am I going to use?
50 scale.
50. What's the most it can read? 50. All right, if it's right here, what is it?
35. 35.
Hey, well, I can look at it and know it's exactly between 30 and 40, so that should be about 35. But let's just make sure. Is it one time we counted by 5s, another time we counted by 2s. Now this time we're going to count by 1s. So it's 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Got it?
Yeah.
You just got to look. Just got to look. What is it right here? Just making up stuff. 22. You guys are just so fast. It is 22. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. It worked out. It's all right? So 50 was easy, wasn't it? All right, so was 10, huh? All right, erase all ink. So what comes after 50? 250. Which scale am I going to use? All right, I'm going to use the 250 scale. This is not hard. This is so easy. I'm going to just put it right here and say, well, how much is that then?
Go by 5.
Yeah,
140.
Everybody wants to say 140?
Yep.
All right, well, this I know right in between has got to be 125 because it's right in between the two. So we can try it 125, 130, 135, 140, and 145, 150. Works out. 150. All right. And let's see. Works out. What's the last one here then? 500. All right, which scale am I going to use? There's no 500. So I guess we can't. What's the most it can read at 500? All right, so all we do is add a 0. We pretend to add a 0.
Still goes up the same way.
Look at that. Same way. All right. So what's the most I can read? 500. So what if it's right here? How much is that?
55.
Well, we can try it. So there's a lot of space in between. Is it by 2s or 1s?
360. 4 more is 400.
I'm going to try it out. So that's 310, 20, 30, 40, 50. Yeah, it's by 10. So this is 310, 320, 330, 340, 350, 360, 370, 380, 390, 400. Is anybody lost? This is really easy, isn't it?
It's
Yeah.
all about
If it is,
converting.
if it's 500 and it is 360, do we have to put like 500.360 or 5.360, or do we just leave it as 360?
Oh, well, okay. So let's just say it was right here. Is that like your question? It's not on a line, is it? So how many volts is that?
263.
All right. So it's how much is this right here? That'd be 250. 210, 20, 30, 40, 250, 260, 270. So it's somewhere between 260 and 270. What do you say it is? He says 265. She says 264. I'm not going to argue with either one of you. All right? You're getting as close as you can. It's your best estimate. Now this is missing something that, let's see here, that a lot of meters have. This one has it. This right here is a mirror. A mirror. Like the thing you should be combing your hair and brushing your teeth into. The purpose of this mirror is to prevent a thing called parallax. Right? Parallax is if I hold out my pen in front of me and I close my right eye, I got it covering the half the doorway. But my left eye now it's covering. It moved out the doorway and over here, right? So you do that and change your eyes and it goes back and forth. Well, it's the same thing with this meter. When the line is there, if I come off to one side and look at the line, it's going to give me one reading. If I go this way, it's going to get another. So the purpose of the mirror is you should look over it and move your head until the reflection of the needle disappears behind the needle. So you should only see one needle, and it tells you you're looking straight down at it. If you're off to one side, you'll see a needle and you'll see a reflection of the needle. And you come and there's no needle, then you move over and there's another needle. And so that's going to give you a parallax. So when I'm working with you and asking you to look at something, I'm actually always going to be off to the side and always be a little bit different to me. And so sometimes I'll really want to get in there and look straight down. That's what I'm doing. But otherwise, I'm looking at it, and I can be as much as, well, it depends on the scale, but I can be a way off if I'm standing way over to the side. So make sure you use the mirror and to prevent parallax.
So you gotta look right over
Look right over it. Otherwise, you're going to be getting some different number. All right, so we've covered ohms. We've covered volts. What's left? Amps. All right, so we got amps. So looking at this particular photo here, where are my amps? I've got 500 mA, 100 mA, 10 mA, and 1 mA. Milliamps. All right, this is going to take some explaining right here. But you know what? I think you guys have been in your chair for another hour, so let's take 10 minutes. And we'll come back to this.
American's tire. That's how Roseville.
Sunshine.
But from south to side, it's pretty far.
You know what's really good?
You working on that?
Huh?
You working on that?
Yeah, I guess. Get out of here, man.
I think most electrons.
What?
That's what I see online. They always just say that shit. Yeah, so what do you do? Oh my god, see, that last time ago, I always get like XXL burritos. That's like my dinner. Because that's something small. Like, any something to fill me up.
I'll give you $5
I really want to I'm gonna go to El Pollo Loco and get a free taco.
$5. I think they're $5.
Nobody pays it. It's $5.
They're like 6. I think there's 6. I'm just kidding, it's $5. Bro. I'm not gonna take less than $5. I need gas money. Plus tax, plus shipping and handling. I gotta handle it.
Yeah, I could smash all the how much money.
I need to get it gas and handle it.
This is American.
Yeah, it's gonna be $3.50 with tax and $1.50 for gas.
I give you probably you give me $5.
I was just thinking, I was like, all the bench away, and then it starts falling, like, it's not broken. How much you give him? $5. Give you $5?
For one chalupa.
Oh, what kind of sauce?
Yeah. Wait, did I just work out of work today?
Bro, so is it just a chalupa, no sugar?
Nope.
Wait, so steak, what kind of meat do you have?
Oh, yeah.
Say that meat, steak.
Well, I mean, if you're that's they offer you the
He's never,
opportunity to
wait,
get
hold
caught
on.
up. So why would you
You'll go for steak?
Well, especially since you
Steak even good?
you have to do good.
So it's not a strip.
I've literally never ate their chicken or steak or beef. Wait, I've never even tried steak. What the heck?
Yeah, they always ask for chicken or steak.
I put all of these classes. Just think about taco bells. Right there, you know, I don't know.
What I like about him so far is what he's talked about, what he's written down on the board is what you need. If he goes off on a tangent, he doesn't write anything down, it's not relevant.
Beef supreme chili.
Same thing, test every Friday.
Yeah, but it's only on one.
It's not like last test where there's 4 different.
No, I already did it.
Yep.
What? You did the test?
Oh.
Yeah. Because it goes into more to that.
Do you know you can do that?
There was one more thing.
No problem.
You got
Burger King's closed already?
Bro, their chicken nuggets, $1.49 for 10.
Maybe you can.
Cause I remember before I bought like 90 chicken nuggets for like, less than $10 I got so sick of it, like I stopped eating chicken.
You guys doing okay? I know this is a lot. This is a big deal what we're going over. Because this is the rest of this week and it is all the next 8 weeks is dealing with this meter. I don't know if I actually stopped it here, so.
Yeah, it's one of those things if you read it wrong.
Yeah, it's still running.